Hello students, welcome to another short video on our Small Steps Good Grade Secondary Science program. Today we are going to do lower secondary chemistry, atoms and molecules. Let's go. So there are some must know that I'm going to go through in this short video. So what are the numbers that you see on the periodic table of elements? Okay, so basically you will see a chemical symbol. And do take note that the chemical symbol, if there are two letters, the first one must be in caps and the second one must be in small letters. All right. And we have the one of them being the atomic mass and the other one being the atomic number, which is the number of protons. In the past, the atomic mass will be at the top and the atomic number will be at the bottom. But now, I do know that since 2020, there has been a change in our periodic table used in GCE O-levels. So don't worry. This is a short version. I cut it out that for you to see. You will see that the smaller number is at the top and then the bigger number is at the bottom. You see, for every one smaller number at the top and the bigger number is at the bottom. So basically, the atomic mass will be at the bottom. How do I know? It's so difficult to memorize, right? Especially during exams and you see so many numbers. There are always legend in the periodic table, okay? So another thing for you to note is, since the atomic mass is the number of protons and the number of neutrons, so definitely the bigger number is the atomic mass and the smaller number is the number of proton, which is the atomic number. All right, so two ways for you to remember. One way is the bigger number is always the atomic mass, which is the number of protons and neutrons. The smaller number is the atomic number, which is the number of proton. So this is how a small section of our new periodic table look like. And I want to highlight to you the vertical columns are called groups. So for example, this is the Romans italic symbol for 3. So this is group 3 and this is group 4. Group number represents the number of valence electron, which is the number of outermost electrons. Later, we are going to do some questions on electronic configuration, and we will show you that if you have 3 valence electrons, you will be positioned in group 3. If the elements has 4 valence electrons, 4 outermost electrons, you will be positioned in group 4. The horizontal rows are called the periods. The period represents the number of electron shell. All right, the number of electron shell. And if you have 3 electron shell, you will be in period 3. And if you have 2 electron shell, you will be in period 2. So for example, aluminium is in period 3, 1, 2, 3, and it is in group 3. So it has 3 outermost electrons and 3 electron shell. You also must know what is in the nucleus and what is free moving. So there are 3 subatomic particles: the protons, the neutrons, and the electrons. The electrons are in the electron shell, is free moving, is lost and gained during chemical reactions. And the protons and neutrons are in the nucleus. So let us take a look for hydrogen. I have 1 here, means I have 1 proton. See, 1 proton in the nucleus. And the number of P is equals to the number of E. All right. Why? Because atom has no charge. It is electrically neutral. So the negative charge electrons will cancel out the positive charge. So therefore, the number of protons must be equals to the number of electrons. So 1 proton 1 electron. Now, let us take a look at carbon. Carbon has 6 protons. It is in red and it is in the nucleus. And it so happened to have 6 neutrons too. How do I know? Because let us take a look at the atomic mass number, which is 12. And this number represents the proton plus the neutrons. I have 6 neutrons. It doesn't mean that the number of neutrons and protons are always the same. It is just for some atoms, you will realize that the number of neutrons is the same as the number of protons. So we will also have 6 electrons because we have 6 protons. So the first shell can only take 2 electrons. So we have 2 electrons and 6 minus 2 is 4, and 4 will be spilled over to the second shell, and therefore the number of valence electron for carbon atom is 4, and hence carbon is in group 4 in the periodic table. What is a molecule? You must know the definition, and not only just memorize the definition, you must have some visualization, all right? So a molecule is a group of atoms that is chemically combined, all right? CO2, carbon dioxide, is one example. Methane, CH4, which is our natural gas, is also one example of molecule. What is an ion? An ion is actually an atom. An ion is an atom with positive or negative charge having lose or gain electrons. If it loses electrons, meaning that there are more protons in the atom than electrons, hence positive charge win, and hence this atom become positively charged. If it gains electrons to form a stable electronic configuration, that means the number of electrons is more than the number of p, and hence it is negatively charged. What is stable electronic configuration? The outermost shell must be 8. Open-ended question time. What is the electronic structure of carbon atom? The electronic structure, if they ask us to draw, we will draw like this, with 2 in the first shell and 4 in the second shell. If they ask us to state, then the electronic structure of carbon is 2.4. The 2 represent the 2 electrons in the first shell, and 4 represent the 4 electrons in the second shell. The second question is, how does electronic structure of an atom relates to its position in the periodic table? So from this electronic configuration, we will be able to see that it has 4 valence electrons and it will be in group 4. So the number of valence electrons of each atom determine the group that the elements will be positioned in the periodic table. For example, carbon has 4 valence electrons and hence it is in group 4 in the periodic table. What are the electronic configuration of aluminium and sulfur atom? So you have to go to your periodic table to take a look at the numbers of protons, and you will get the number of electrons, right? And you have it. The electronic configuration of aluminium is 2.8.3. The proton number for aluminium is 13. So the number of electrons for aluminium will be 13 too. The first shell will be 2. The second shell will be 8 because the maximum number of electrons for our electron shell is 8 in GCE O levels. All right. When you go up to higher levels or when you go JC, you will realize that, oh, that is not the case. But for GCE O levels, it is 8, all right? And then we will have the last 3 electrons floating and moving in the third shell. Therefore, we have 2.8.3. And the electronic configuration of sulfur is 2.8.6 because the proton number is 16. Therefore, it has 16 electrons. You can do the allocation 2.8.6. The first shell can only take 2. The second and the third shell onwards, you can take up to maximum 8 electrons. And therefore, 2.8, you are left with 6 electrons and it will be in the third shell. Why aluminium and sulfur are in the same period in the periodic table of elements? Let us take a look at the electronic configuration. Periods represent the number of shells, electron shells, right? So for aluminium, it has how many electron shells? 3. So sulfur, it also has 3 electron shells. So therefore, both aluminium and sulfur atoms have 3 electron shells, and hence they are in the same period, period 3 in the periodic table of elements. Fill out the table with the correct number of subatomic particles for sodium atom and sodium ion. Now, we are given this chemical symbol, and the bigger number is the atomic mass, which is the number of proton and neutrons. So in order to take a look at the number of protons, we take a look at the atomic number, which is 11. So we have 11 proton. And how do we get the number of neutrons? We use 23 minus 11 because 23 is the total number of proton and neutrons. We will get 12 neutrons, and the number of electrons is 11. Correct, because for an atom, the number of protons must be equal to the number of electrons because an atom is electrically neutral. However, it is not the same for an ion. An ion has a positive or negative charge. So for this, before we start filling up the blanks, we should ask ourselves whether sodium will become a positive ion or a negative ion. Sodium is in group 1 because the electronic configuration is 2.8.1. It is in group 1. And I have actually went through how do we determine the charge on ions in another short video. Please go and have a look in the micro lessons. So for group 1 atoms, they will lose 1 electrons to form a stable electronic configuration. When you do 1 homework or 7 homework to achieve the same result, you will do 1 homework, right? So sodium will lose 1. In fact, all metal atoms lose electrons to form a stable electronic configuration. Whereas for non-metals like chlorine is in group 7. In order to fulfill 8, it either gain 1 or it has to lose 7. So it will gain 1. So therefore, our non-metals will form negative ion by gaining electrons. So for sodium, the number of protons remains the same. So it's 11. The number of neutrons didn't change. It is in the nucleus. It cannot go anywhere. So it is 12 as well. For the number of electrons, it is no longer 11. So please take note, this type of question is a little bit tricky for students because they thought that the number of protons is always equal to the number of electrons. So 11, you're going to lose 1, right? Because sodium is in group 1 and hence it is 10 electrons. So now let's do the same practice with a non-metal atom, nitrogen. All right. So the number of proton, yes, is 7. Let's take a look at the atomic number and pull it down. The number of proton is 7. The number of neutrons also happen to be 7 because 14 minus 7 is 7. And the number of electron is, yes, 7 as well because the number of proton equals to the number of electrons for an atom. For ion, No, it's not the case, but yes, the number of protons still remain the same. Neutrons still remain the same. But for electrons, let's determine what group nitrogen is in. Electrons. So therefore, the electronic configuration is 2.5. So it is in group 5. And group 5 will gain 3 electrons to form a stable electronic configuration. All right. It wouldn't lose 5 because 5 is a bigger number than 3. So it just gained 3. So nitrogen will gain 3 electrons to form N3 minus. And after gaining 3 electrons, the number of electrons is 10. So it is possible for ions of different atoms to have the same number of electrons. Just now, sodium ion also have 10 electrons. Now, nitrogen ion also have 10 electrons. Question 7, the last question, what are the 2 examples of atoms and molecules in our daily life? So let's take a look at the picture so that we have some visualization of atom. When we talk about atoms, the question will always ask us about proton, neutrons, electrons, all right? Because these are the subatomic particles. And when we talk about molecules, it looks like this. It has different sizes of atoms together if it is a molecule of a compound. We will also have molecule having the same type of atom, which is like O2, N2, H2, Cl2. They are all molecules too, all right? So I would like to give you 2 examples. You can have more than that. Helium and argon gas are some of the atoms that is in our daily life because they are in group 8. They do not need to form molecule. They are already stable, all right? Helium gas, argon gas. Now, the rest of the gas, like oxygen, will not exist as an atom. They will exist as O2 because they are not stable. And some of the molecule that I have given is CH2 and H3. The 2 and the 3 must be the subscript, not written as a whole like this. And you can also write Cl2, O2. These are all examples of molecules. I hope this short video blesses you as usual. And thanks for watching. Follow for more.